This is a Key Stage 4 introduction to the concept of electrical current. So on screen we can see a lightning strike. This is an electrical current flowing through the air. So the questions are, what is the electrical current made of? And what is it that makes it travel through the air? So the title today is Electrical Current. We should be able to describe what an electrical current is, state the equation for electrical current, state the SI units of charge, current and time, state what is required for an electrical current to flow, and finally describe what potential difference is. So the matter we see around us is made of atoms. Atoms are very small particles, but they themselves are made of smaller particles. In the center of an atom, bound in the nucleus, are protons and neutrons. The protons are positively charged. The neutrons are neutral, which means they are zero charge. While on the outside of an atom, electrons orbit the nucleus. It is the ability of these electrons to be passed from one atom to the next which allows electrical current to flow. So if we consider the idea of current as a flow of charge, we can see that current is equal to charge per unit time. That is to say that if you have a large amount of charge flowing past a point, but it is flowing slowly, you will have a large current. If you have a small number of electrons, a small charge flowing slowly, then you will have a small current. But if you have a small number of electrons flowing very quickly, that is a large current. It is all about how many electrons pass a point in a circuit in a given amount of time. If lots of electrons pass in 1 second, that is a large current. So let's take a look at the units. We have current is equal to charge per unit time. Charge is measured in coulombs. Time is measured in seconds. And current is measured in amperes. So that is to say that 1 amp is 1 coulomb per second. Next, potential difference. Potential difference is the push and the pull that allows electricity to flow. It is the force that's provided to these electrons to make them pass from one atom to the next. In this example, we have a voltage on the right of minus 50,000 volts and a voltage on the left of plus 50,000 volts. The potential difference is the difference between these two numbers. The difference in potential here is 100,000 volts. Now, to travel through air, electrons need approximately 10,000 volts for every centimeter. This suggests that the potential difference across this gap means that there must be a gap of around 10 centimeters. Now, the important thing to note, the potential difference, the push that makes the electrons flow from one object to the other, does not have to be equal and opposite. It could in fact be that we have minus 80,000 volts on the right and plus 20,000 volts on the left. It is not about the individual number, but the difference between them. Equally, if one of these metal objects was 100,000 volts and the other one was at 0 volts, the potential difference would still be 100,000 volts.